These two Anritsu signal analyzer models cover different measurement needs. The high-end MS2690xA is based on a high-performance spectrum analyzer for the 31.25 MHz analysis bandwidth and has a built-in signal analyzer. It's the perfect combination of performance and functionality for R&D. The middle rank MS2830A has a wider range of general applications using a simple spectrum analyzer in combination with the signal analyzer. The MS2690xA Platform is a spectrum analyzer that also has signal analyzer functions as standard features. It's perfect for R&D applications because the signal analyzer function can be used to check signal performance that cannot be observed with a spectrum analyzer using FFT. Adding the optional vector signal generator allows the output of reference signals for parts evaluation. Both modulated and continuous waves can be output. The MS269xA has best-of-class performance of all general-purpose spectrum analyzers. X Company's general-purpose spectrum analyzer is only calibrated for one frequency point, so there are large errors when frequency and attenuations are changed. However, the MS2830A's unique technology supports level correction over a wide frequency range from 300 kHz to 4 GHz, so it supports stable measurement with excellent level accuracy even when frequency and attenuation are changed. Eliminating point-to-point margins increases yields by cutting the number of invalid measurements. The standard spectrum analyzer functions support all measurements for testing transmitter characteristics. The parameters of the ACLR measurements can be set by selecting templates. In addition, changing in-band channels from 1 to 12 is instantaneous. The spurious function divides the measuring frequency range into a maximum of 20 segments and sets each spectrum analyzer parameter and limit line. It supports continuous automatic measurements for 20 segments and displays each peak value. The spectrum mask function sets parameters and limit lines for a maximum of 6 segments symmetrically on each side of the center frequency. Support for both absolute and reference level measurements is fully standards compliant. The occupied bandwidth function parameters are set by selecting standards templates. The N% and XdB measurements are fully standards compliant. The channel power function measures power in the specified frequency bandwidth. Rectangular, Nyquist, and root Nyquist filters are supported. The burst average power function measures power between two markers. It's convenient for measuring the power of burst on and burst off signals. The multi and zone markers function places up to 10 markers at any location. The marker width may be either spot or zone. When measuring peak power with a zone marker, peaks in the range are detected automatically, ensuring that all peaks are measured even when there's some slight frequency fluctuation. In addition, the powers of up to 10 points are displayed as a list. The frequency counter function measures CW signals. It supports high-accuracy frequency measurements under 1 Hz. The MS2690xA built-in signal analyzer function supports FFT analysis with a 31.25 MHz bandwidth. As an option, the bandwidth can be expanded to 125 MHz. The signal analyzer supports FFT analysis of signals in a specified analysis bandwidth and displays 5 trace screens. The spectrum function continuously captures and displays signals in the set bandwidth for the set time. It can be used to simultaneously check spectrums that cannot be checked with a conventional sweep-type spectrum analyzer. It's ideal for checking transient fluctuations and burst signal rise and fall times. The frequency versus time display confirms frequency changes using a graph with frequency on the vertical axis and time on the horizontal. It can be used to measure the frequency shift of FM signals. The amplitude versus time display confirms changes in amplitude using a graph with amplitude on the vertical axis and time on the horizontal. It can be used to check fluctuations of burst signals in the time domain. Another function of the amplitude versus time display is measuring the modulation of AM signals. The CCDF display indicates the cumulative distribution of transient power variations compared to average power. By comparing with a Gaussian trace, it's possible to save the CCDF waveform as a reference for comparison. The APD display indicates the probability distribution of transient power fluctuations compared to average power. The spectrogram displays levels in different colors on a graph with frequency on the vertical axis and time on the horizontal. It's a key function for finding points with transient fluctuations. Additionally, it can also be used for hopping and chirping signals. 5 screens can be selected for the main trace and 2 for the subtrace. The main trace zoom displays the selected blue part of the subtrace. Transients in captured long-term data can be selected at the subtrace for zoom display on the main trace to see the fine details. Adding measurement software to the signal analyzer supports EVM and constellation measurements. The MS2690xA supports all major wireless communication systems. Installing each software license supports modulation analysis. RF signals, analysis bandwidth multiplied by analysis time, are captured to the internal memory. Even transient signals that cannot be observed with a conventional sweep-type spectrum analyzer are captured so nothing is missed. Captured signals are saved to hard disk for replay to confirm trace signals at any time. Generally, when capturing RF signals, the saved data may be degraded by the measuring instrument's own internal characteristics. When the user implements this data at simulation, correction of the data can be very difficult. However, with the MS2690xA, data is saved after correcting for internal degradation, so the user can perform simulations on captured data without further correction. The maximum sampling rate is 200 MHz when capturing signals at 125 MHz bandwidth. For example, RF signals can be captured with a resolution of 5 nanoseconds. Signals with multiple frequency components, such as motor noise, are easily captured under these conditions, approximating real signals. In addition to IQ data captured by the signal analyzer, patterns can be generated by the built-in vector signal generator to reproduce very similar signals for output. Faulty operation due to noise not only tarnishes brand image, but also causes serious and fatal accidents. However, laboratory troubleshooting of the various causes of instrument time and place-related noise in the field is almost impossible. But capturing noise with the MS2690xA and replaying it in the laboratory from the signal generator makes noise troubleshooting much easier. A built-in vector signal generator can be added as an option to the MS2690xA spectrum and signal analyzer functions. It has the same performance, including level accuracy and RF bandwidth, as a general-purpose vector signal generator. The vector signal generator function is based on arbitrary waveform memory with pre-installed general wireless communications waveform patterns. In addition, the built-in AWGN generator is useful for measuring signals with different carrier-to-noise ratios. The vector signal generator has a built-in AWGN generator to output wanted waveforms with AWGN of any level added. The vector signal generator waveform patterns are saved in the internal hard disk. Required patterns are saved to memory to output various modulation signals simply by selecting from memory. The standard built-in memory holds 256 megasamples, or 4 times more than general signal generators, and supports batch loading. The IQ Producer PC software generates waveform patterns for the vector signal generator option. Communications methods without standard waveform patterns, such as LTE and WiMAX, can be generated by IQ Producer. IQ Producer can be used as soon as the license is installed in the MS2690xA. The MS2690xA is a multi-function spectrum analyzer platform that's easily expanded by adding options supporting a wide range of measurement solutions. It's the ideal instrument for your evaluation environment.